Good evening and good afternoon, good morning to all of you to this IDC talk number 28. On behalf of the alumni, I'm very happy to invite Arivazhagan, popularly more known as Ari, from the 93 batch PD. Um, it's a very interesting take that Ari is going to cover today on EV. I mean, EV, electric vehicle, as we know, has got very various dimensions to it, and there are questions like when am I going to get my first one? Is it good time, or we wait for 5 years, 6 years? This is the consumer side of thinking that goes on. But at the same time, there are things that happen from the insiders, the designers who are part of this. And Ari represents the designer community, which looks at EV. And very interesting that over the last week, when we had this conversation, he came with this very interesting set of questions. What, as a designer who is part of the game from inside, is asking. He is asking how to look at this EV. Is this I know EV is inevitable. So he's saying, as a designer, how do I look at it if I see it as a change, which means that I have to adapt to this new thing that's coming, and what if I see it as a change, how do I look at it? Or other way is, if I see it as a challenge, how do I look at it? Or if I see it as yet another thing that happens in business, some new thing will come and the business will just take it up and do, which he calls as a Chalegaa types. So he says all these three kind of questions keep crowding his mind when he thinks of this topic of EV. So we thought that could be a very nice take of his, which he can share to this forum, and that's how we started. And to give a brief about Ari, Ari is an industrial designer. He's been in the automotive industry. After his architecture, he did his master's from IDC, then did his specialization in automobile in Coventry, UK. He has worked with some of the best brands. He has worked with Nissan Infiniti, McLaren, and now JLR. Anybody, a junior who looks at his resume, would be like so excited to be part of this brand, and that's the kind of experience that Ari has. Very focused, very passionate about what he does, and Ari is always known as a man of eye for exquisite detail, and I'm sure he links that to that pride, and he has a lot of fan following for this reason. And it's such a great honor, and also such a pleasure to listen to Ari, and I'm sure all of us will have an exciting session of listening to him. Thank you, and on your behalf, I will hand over the session to Ari, and over to you, Ari.
Yeah, thank you, Ravi. It was a great introduction. Yeah, let's start with the session now. So, you will see.
Yes, we are good.
Yeah. Okay. Good. Yeah. So, good evening, everyone. Thanks for your time. Tonight, we are going to look at the role of BEV in our current car culture. Is it a change, challenge, or chalega? We see the whole in a holistic way how the BEV is affecting all of us. That's the theme of this talk. Let's move on to it. Since the first ever stone tools were made, a car is the most sophisticated consumer product today, embedded with so much of socio-economic, cultural, and emotional values in it. They entice our sensory systems: visual, auditory, tactile, olfactory, and all the other emotional things. There's no other product could create such an impact on us. They elicit emotions within us and among everyone. The complex nature of the product triggers mixed emotions, and different aspects of the design: proportion, volume, line, texture, surface, material, and light. They play a visual drama on their own and as a collective. One may like the attitude of the car and the brand, but may not like the new feature on the body side and on the front fascia. This kind of clash of emotions nurtures the relationship between them. Car consumption is never just about functional or financial choice, but it's as much as an aesthetic and emotional and sensory response to driving because it triggers emotional peaks next to a roller coaster, a bus moment like roller coaster. Cars are epitome of independence, a tool to make memories, a chance to explore new places and discover fresh sights and sounds. The incremental health of handling speed from finding the biting point, stalling at the traffic lights, and taking the right exit on the roundabout, and great parallel parking create lasting memories in us. Pleasure of driving is not just an act itself, but it boosts cognitive function as well. Automobiles have impacted everything from art, design, engineering, manufacturing, marketing, travel, and environment in its 140-year history. It has forever been the agent of change and will be for the days to come. It has accelerated the pace of progress like no other product. Cars was not invented by one person or a group, but its culmination of worldwide series of experiments, developments on single theme, safe and sensible mobility using the science and technology of that time. Man's most instinctive urge is to move from place to place with his belongings and people in comfort. Therefore, he devised a many variety of carts, carriages, coaches of different sizes and purposes since he invented the wheel and tamed animals. Man used turning cranks and moving levers and jets of steam for propulsion. The pictured one is a history, the steam powered tiller done by Nicolas Joseph, a French military engineer. It's used in agricultural implements. 18th century is dotted with so much of experiments and advancement on this. Various people were experimenting with piston cylinder engine using steam and explosion of gunpowder as power source. None of them unseated the horse and buggy. In 1820s, some Englishmen built a commercially operated steam vehicles to carry passengers and cargo. Public were wary of machines which frightened them and their horses. Conservative countrymen were restricting its operations on the public roads since they were noisy, often breaks down and sometimes explodes. So this forced the development of carriages on private rail and led to the birth of railroads. In the meantime, French engineer Lenoir invented the internal combustion engine using illuminated gas lit by an electric spark in 1860 to drive machineries in production facilities. Then Otto of Germany, he fine-tuned this to four-stroke cycle in 1866. In 1885, Daimler picked up this and improved it and manufactured in volumes. This Daimler engine was used in Arivazhagan design vehicle, which set the basic mechanical pattern of automobile of modern days. Steam, electric charge, and gas were used as source of power. They all had its own advantages, disadvantages, supporters, and haters. Steam took long time to build up pressure, difficulty storing enough fuel and water for long trips. Electric cars were quiet and easy to operate, but extremely heavy, could go only so far, took long time to recharge. But however, petrol-powered were quick, could run for long distance between refill. Discovery of oil fields in Texas in 1901 fueled the development of petrol vehicles and its dominance over other power sources. And these petrol automobiles were produced by Haynes, Ransom Old, Charles King, and Henry Ford between 1894 and 96. So automobile races stirred public interest, converted buggy and bicycle manufacturers to automakers. Like motorsports, successful expeditions such as Citroen Auto Channel crossing Sahara in 1922 also ingrained that the cars may take you so far, and they also added much advancements to the road cars. When industry adopted Charles Kettering's electric starter system In place of hand cranks, it was practical for women to drive. As more demand generated, production and supply system were fine-tuned and mastered to place inexpensive cars in the hands of average people and remove the label of rich man's toy. When the when they built cars with closed bodies, which could be driven in all weather, it became essential means of passenger transportation. When everyone was mastering how to build an affordable car, men like Alfred Sloan, Harley Earl, and Chrysler were concerned about automobiles' relevance in life of consumer. Buyer's choice became watchword. Automakers took styling and vehicle options to new heights. It became as much a statement of personality as mode of transportation. Designing cars is all about specific consumer and market needs. Cars have to be fresh, new, yet show all the characters of most successful products in the market. It is about satisfying the customer, market, and the people who sell it. Nevertheless, only few makers have survived since initiation. Many have reorganized, merged, and dissolved. Automotive technology is, as a system, involves not only the industrial production of cars, but also infrastructure and superstructure associated with their use, maintenance, and recycling. Cars have many dimensions such as social, economical, cultural, political, and environmental than the being a product of technology. Automakers have responded diligently to the regulatory measures on emissions, market demands, but technological paradigm behind car design and manufacture substantially limits their alternatives to them. Today, around 1 billion cars and trucks are on the job of moving people and goods worldwide. Such a remarkable feat has been achieved with little change to the machine that was invented in Carl Benz and popularized by Henry Ford for the more than a century ago. The basic design automobile is same as it was in 1900. The transport system has remained stable because of its complexity. People and businesses derive value from all parts of the system working together: vehicles, roads, regulations, vehicle standards, and train drivers. Vehicle combustion engines account 1/5 of the world's carbon dioxide emissions. European Union limiting emissions to 80 grams per kilometer. Each time emission regulations are tightened, European automakers lobbied against them. However, the data shows that the cars were getting cleaner and cleaner because they have to comply. Automakers have been producing electric cars in order to lower their fleet average to make up for their polluting cars. They also motivated only when the tighter emission limits came into force every 5 years. National and local governments are using no-car zones and car-free days, penalties to enter the city, highly polluting cars as a deterrence to keep the city's air clean. Average speed in cities as low as 20 kilometers per hour, with ever-extending journey time for the same distance, irrespective of what is under the hood. Road transport, as we know, is not sustainable. With fast melting glaciers and rising sea level, changing in climate, growing environmental activism among new millennials have prompted the world leaders to make note and take steps to slow down the impact. Around 24 countries, including Canada, New Zealand, Netherlands, Ireland, UK, and car companies like Ford, Volvo, and Mercedes-Benz, and regional governments like New York, London, Barcelona, and a group of financiers and fleet owners have pledged to phase out of fossil fuel cars by 2040. So, weakening demand in China, sliding diesel vehicle sales due to Dieselgate, scaling down of overexpanded manufacturing facilities globally are difficulties faced by auto industry now. Silicon Valley becomes just as important to the industry's future direction now. Like many companies are working on autonomous vehicles and passenger hail system. Automotive industry faces fundamental threats, according to Professor Carl Williams. The car, as we know of it, may be on the edge of becoming history, the way Kodak became one. It is not at all clear which manufacturer in diesel and petrol vehicle will be in benefit from electric and autonomous vehicles. BEV and ICE vehicles are two ends of the same stick, and software takes precedence over hardware. Battery technology and battery management technology are the deal breaker in this fight. Those who don't have them in-house suffer at the cost of suppliers, similar to the chip shortage during the pandemic. BIV assembly is different from ICE cars. Building new lines from scratch is tricky for the legacy firms. Skills and talents required are different and few in numbers. This affects the union. A dealership network is another issue for the legacy firms where Tesla sells their cars directly to the customers. Servicing, maintenance, and EV are almost none compared to the ICE vehicles. This is another pinching point for the dealers. Tesla has established itself as synonym of electric cars since 2008, whereas legacy firms yet to join the fray. This is their readiness level. Like Volvo is already cross thing, and Toyota is yet to start. So, as countries plan to gradually phase out petrol and diesel engines, automakers adopting electrification as a stopgap strategy until they transform into BEV-only brands. Electrification is shift from mechanical to electric power. It means fixing an electric motor to assist the efficiency of the petrol engine or to power the whole car. Such powertrains are called a hybrid, mild hybrid, and plug-in hybrid. Volvo is the first major car maker who went complete electrification in early 2019. See, in ICE vehicles, the number of cylinders, layout, bore, stroke, compression ratio, turbocharging, supercharging, and the sound creates the character, resulting in difference between the muscle car and the simple city car. The internal combustion engine, the extraordinary force which revolutionized the world as we live in today, from transport to production for better human life, is being muted out on the pretext of going clean and green. In coming years, internal combustion engine may be of a history where we'll be buzzing about in electric cars. Car brands that used to rely on engineering superiority now no longer has the advantage. The power plant is no longer the key battleground. So bold new design and renewed emphasis on brand identity through aesthetics are taking center stage in order to shape the customers to the future of mobility. They have gone two-dimensional, and they have a subtle and monochrome electric blue accent in all their logos. And battery electric vehicles are fairly simple and easy to operate. A simple power train architecture consists of high voltage electric motors and a battery packs in the middle. And one single speed gearbox. The most important advantage of BEV is overall high efficiency, reliability, and relatively low cost of the electric motors. The main drawback is low energy density of the high voltage battery. Skateboard platform, which was developed by GM 20 years ago, is well adopted by Tesla, Rivian, and Byton. In this architecture, the length and breadth of the undercarriage assembly can be adjusted depending upon EV models. So this is a Hyundai platform. So the battery being the heaviest electric component of the vehicle, it gives a very low center of gravity, which improves overall stability of the vehicle. The nominal voltage is between 360 and 450 volts, and there's a 12-volt battery to run power lighting and multimedia. There are different types of high voltage batteries. Chemistry is the main distinct factor. The most common HV battery is lithium ion, but however, lithium ion phosphate batteries are most suitable because they're safer in terms of chemical and thermal hazard. These are the conventional architecture for vehicles used. This is a ladder technology is used for light commercial vehicles, and the monocoque is used for passenger vehicles. Modular EV platforms are generated for BEVs. These modular EV platforms will accelerate vehicle electrification, focusing on ways of lower cost, increasing driving range, revolutionize next generation EV architecture for scaling EV mobility. BEV architecture has powertrain in the front and the rear, at times both for four-wheel drive or at times on the wheels for high-performance vehicles. The battery pack is between the two axles, and this gives more volume for the passenger area and little bit under the hood and the trunk. In all possibilities, electric cars make better use of the longitudinal space. Either they'll be compact or more habitable. The front end may be shorter and steeper without compromising the aerodynamics and crash and pedestrian safety regulations. The batteries between the wheels are better balancing the two powertrains. So, however, it increases the ride height by 150 minimum. So that's why most of the debut debut BEVs are more crossover like or SUV, and so design head of Polestar, Maxwell Missoni, he says the size and position of electric motors versus combustion engines allows shorter overhangs, more compact and sportier front volumes, and more interior space within the same footprint. And Ian Callum, the former design director, reflects the same thing. He says it will give design teams more opportunity to try different things, and those things that then become more exciting. I think it gives the designers more freedom. So based on the range, maximum speed, acceleration, and performance, BEVs are classified as neighborhood, city, and performance EVs. We can see the cost to the range relationship. And apart from heading towards achieving the price parity of BEV against ICE vehicles, a few other trends are emerging in EV sector. Vehicle to grid, where batteries of the parked cars will store electricity during peak production and feed the grid back when needed. The other one is once the EV batteries have done their quality road miles, they are redeployed as stationary energy storage devices to store energy from renewable sources such as solar, wind, and the like. They're also used in portable recharges for the fleets. See, trends in car design get shaken up every 10 years, but shape vocabulary of automobile has remained largely the same for the century. Now, electrification is changing the automotive industry irrevocably. At the start of the 20th century, mobility, freedom, individual personality were expressed to the outside world through aesthetics of the products we own. In the 21st century, EV manufacturers are tapping into the concerns and priorities of new generations: durable products, environmental sustainability, affordability, ease of access over individual ownership, and showmanship. During this transition period, there will be some uncertainty among customers looking at the electric vehicle market. But even during the slow period of adoption, design of vehicles due to change inevitably. Cars are designed to appeal our subconscious, which decides whether we like the car or not, and ultimately influences the purchase. Styling is really important to make or break the car. On the other hand, we like things what we used to. This poses the first aesthetic problems of electric cars, because as they need much less cooling than petrol cars, the front grille could go much smaller, even disappear. We are used to relatively larger air intakes and very often with shapes reminiscent of a mouth. So a car without a grill or with small grill would seem strange to us. It's like face without a mouth. That's why they've gone a grin is better than none. You can see all these ranges. They all act different roles. Like in I-Pace, it is kind of an arrow feature. It scoops the arrow into it. In BMW, they call it a shy panel, where it hides advanced driver assistance system. And you can see these LiDAR radars at the lower area, and rest of all just. And in fact, Renault is using this badge as their feeding point of the electric plug. Yeah. Next is good aerodynamics and low air resistance play a major role in achieving higher range with the charge available in the battery pack. Adding more batteries to extend the range would be counterproductive as it adds to the weight of the car. So BEV exteriors have been pushed to reduce the drag coefficient to the lowest. Lucid Air, Tesla S, and Mercedes are the winners at the league table now. So basically, the top portion contributes 50% of the drag, and the lower is 25, and the wheels so 25% each. So the car, yeah, these are the side silhouettes of the cars. They all follow a typical aerodynamic governed profiles. Yeah, you can see the steep windshield in all the cars. Yeah. Yeah. Next one is alloys are an important element of style, performance, and power statements. Often calipers shout out from the wheel well. In BEV, braking is used to regenerate power. Wheels need to enhance aerodynamics, so BEV alloys have gone shallow and filled with aero features. In pursuit of catching up with Tesla and many fronts, for well-known reasons, the legacy brands styling is still on the lines of the recent models. Very few has taken a radical route of retro styling like Honda E and Polestar 1. They are so adorable, and they have captured the characters of first-gen Civic and Volvo P1800 in a very retro, modern, stylistic way. We can see the features, it's quickly recognizable, the rear haunch and the front bumper and this silhouette. So next is the conversion. It's about the public appeal to EV. Conversion to EV is seen as a major pillar of climate policy by many governments around the world. Electric cars are quieter, have a faster acceleration. Once motorists have one, 91% doesn't want to go back to the ICE vehicles. Although they are cheaper to run due to rising petrol and diesel prices, their purchase price is limiting factor for many. 78% of the motorists think that they're very expensive for their ICE vehicle similar size. Even that price, you can get only no-frill basic models. Other concern is more the range and the charge anxiety, which hampers the adoption rate. One worries about how far they can go with next available public charging station, and what type and how long is going to be the wait. It is totally opposite to the routine in practice now. ICE vehicles needs few minutes to refill at the forecourt. That convenience is hard to beat with the current range and battery types and charging time. Fast charging is a fix. Fast charging stations are a fix, but it strains the grid and it also compromises the battery life. Bloomberg says that battery prices are going to come down to $60 per kilowatt hour by the end of decade. As battery prices plunging and the lithium ion technology is improving, even power hungry SUVs can go electric. There is a good rate. A personal account of Roscoe World documents her miserable experiences on charging Renault Zoe on a road trip. She concludes that electric car did not widen her horizons, but it has made her plan more carefully for reaching them. Electric cars are common in high-income neighborhoods. They are early to adopt and continue to buy at a higher prices, suggesting that both socioeconomic status and exposure to the vehicles play a major role. Typically, they are high-income individuals, single-family homes recommended by early adopters. Mr. Gilthal of Plug-in Hybrid and Electric Vehicle Research Center, University of California. He says there's no one reason which they give there's a bundle of things like a good environment, 0 to 60, and 20 pound savings per $20 savings a week. It's a bundle that works for the people to go for electric vehicle. So the government incentives mostly help affluent buyers and subsidizes their luxury than the average families. Many were drawn in by the technology novelty, thinking that is sleek, sexy, and better than the big sporty sedans. Very few cited environmental consideration as a prime motivator for switching to EV. Local governments are addressing some barriers in low-income groups adopting to EVs through car-sharing programs and installed chargers in communities where many live in apartments and houses without garages. New bills are to be wired for easy installation of car chargers, and the electric utility companies are trying to encourage EVs by installing more public charging stations. So inadequate public charging infrastructure is forcing drivers to do risky practices of daisy chaining the extension cables to reach their car from the home mains, and they also sometimes leave it in the rain, which leads to health and safety concerns. Although battery technology is improving at all time, affordable BEVs range is very less. They are limited to cities and not suitable for long distances. So the batteries deplete when hatchback, infotainments, electrics, and wind resistance contribute to the journey. Sorry, EVs are now new smartphones which we can't jet out without fully charged. There is a study saying, what do you call? Sorry. In a study recently published, the conventional take is electric vehicles were more expensive in more early days, technically inferior. Infrastructure came too late, and limited access to the electricity constrained the electric vehicle to take on against the gas vehicles. So the alternative arrangement is swapping battery, where NIO has installed 700 battery swap stations in China, which takes 3 minutes to swap the battery, but it is what do you call? It's sorry. The main factors stacked against it is like the cost of installation, complexity of operations, and developments in rapid charge and battery capacity improving. And the batteries play a major role in differentiating manufacturers to manufacturer. In order to battery swapping, they don't want to leave their competitive advantage over rivals. So at first glance, the battery swap may be advantageous for the EV drivers by eliminating the downside of ownership and charging time, but it has a great deal of promise when range is short and infrastructure is not ready. So green number plates could unlock incentives for drivers and increase awareness of clean vehicles on the roads, showing people that greener transport vehicles, the future is within our grasp. Downside of the scheme is UK security watchdog says it allows thieves, and RCA points out that the incentives affordable by the green plates are unsustainable when the numbers of cars goes up. So other one is like it's reliability. There are a lot of reliability issues: in-car electronics, noises, leaks, power equipment, climate system, and body hardware and drive system, paint and trim. In all means, the important point is that the consumer reports found high rates of owner satisfaction, indicating that many EV owners aren't too worried about reliability issues. Now, under EV, EVs are so quiet that it has chances of what do you call it? There are chances of other road users not noticing it. So EU has come out, reviewed the law that electric cars should have noise as their counterparts like petrol vehicles. Under this new law, the hybrid vehicles and electric vehicles will artificially generate sound of engine revving below. Some electric cars, such as Nissan Leaf, is not adequate and it is not recognizable as the sound of the car. Ravi, please play that Nissan Leaf one, please.
Yeah, I'm playing.
Yeah.
Yeah.
Yeah. Yeah, this is kind of a more mechanical than. Oh. That they don't emit fumes such as nitrogen dioxide, but still produce a large amount of tiny particles from wear of brake discs and tires. So he's talking of growing urbanization. We need to manage and plan to reach the global aspirations from improving air quality and human health, maintaining economic success, and combating climate. The Friends of Earth Air Pollution campaigner says that electric cars are critical in fight against the climate change and deadly air pollution, but they're not the panacea. Future of Transport London says that EVs don't solve the problems associated with the volume of traffic on the roads. The greater the level of traffic, the greater danger of death and injury, need for more and wider roads, creating no-go areas, and people cutting off communities from each other. In fact, electric cars become cheaper and continue to benefit from the tax relief. The total number of cars may well rise, add to the problems. Too much of reliance on cars promote a sedentary lifestyle and health risks. Electric cars can also may not produce toxic emissions at the point of use, but as with all cars, embodies carbon in production of vehicles and batteries. The raw materials for making cars have to be mined, processed before they can be used to build cars. All these generate a lot of greenhouse gases. Manufacturing ICE or BEV vehicles produces 7 to 10 tons of CO2. We have to add a battery production into account. Like there is an estimate of 150 kg of CO2 per kilowatt hour. So BEV is also equally bad for the environment, and the impact varies depends upon how the electricity is produced. Batteries need a rare material like lithium. They also need nickel, cobalt, copper, and aluminum. The lithium extraction is an important reminder that any sort of economic boom of certain material unfortunately tends to result in a rush to the bottom of environment and ethical standards. And Oliver Belch mentions that EVs are not driven by eco-minded urbanites but parked in front of their house. Elements used in some batteries chemistries like a cobalt are associated with a non-transparent uncontrolled mining hazard in a hazardous conditions, including child labor and human rights abuse in countries like the Democratic Republic of Congo. And every new petrol car being sold will make 20 years to turnover. Reports suggest that only 30% of the cars will be electric by 2050 under current policies. It will therefore take years before transition to electric vehicles to make a dent on the rising level of greenhouse gases from the transport sector. There is a kind of a history repeating. In 1890, biggest cities in which horse-drawn vehicles were problems, the accumulation of horse manure associated with the stench leading to public health issues. As a result, many people died. To make matter worse, when overworked horse dropped dead, the bodies were let to rot before being removed. Paradoxically, advent of steam locomotive increased the traffic between cities. So this increased the number of horse pulled transport numbers, and so it deepened the dependency of the horses. In 1870, in America, the horse population grew 4 times and the humans were doubled. So the horse were indispensable and sustainable. So the advocates of new emerging technology, then the solution seemed to be obvious: to get rid of the horses and replace them with self-propelled motor vehicles, known as at the time horseless carriages. Now we call them cars. Considering the concerns and priorities, the complexities of the time and the system we are living in, it feels that we are at the cusp of a punctuated equilibrium in mobility, which is slowly, steadily, but surely moving towards more intelligent way of moving around in future. In all means, we will be part of the traffic as ever. I thank you.
Great presentation, Hari. Thanks.
Too much, and
Thanks,
I
Hari.
cramped and lost.
Thanks, Hari. Let me open the house for any questions. Anybody?
Ravi, very good evening. Can I ask a question?
Please go ahead.
Yeah, yes, of course.
Please go ahead.
Arivazhagan, it was very exhaustive and wonderful presentation of the overall global perspective of EV. My question is, what I've been reading or seeing the research in past 5-10 years.
Yeah.
I think we lost him.
We lost.
I wanted to just understand your take on how does graphene battery you feel that will be more safer down the line than lithium ion. Lithium ion, they still feel that whether it is in mobile or others, still there is a danger of almost everyone carrying a kind of a bomb. So how do you see the graphene, which is more environment friendly battery, that is supercapacitors, than this lithium ion? Any take on that?
Actually, I don't have much information on that. I just read something about the phosphate one, lithium iron phosphate one, which is very stable in impact and thermal, in collisions or something. So it's better than the lithium ion batteries.
Probably, Ari, you can, if there is a material on that you want to share, you could share it to Pune actually.
Yeah,
share it to us,
this is a new information. I'll look into it.
Yeah. Anyone else has a question?
Questions in the chat.
Okay.
Is it,
yeah.
Punch?
Oh, sorry.
I'm asking very. I'm at throw here. Basic fundamental. Ravi is the electric motor replaced the IC engine, right? And all the rest of the mechanical inefficiencies are still existing, like a differential box and all those things are still existing.
No, they're not there. Differential is not there. It's all controlled by the electric motors.
Yeah. So how the transmission takes place and the variation of the speed happens when if you don't have a differential?
This is more engineering question actually. We just get to the thing.
Yeah, but you see, ideally, it's supposed to be propagated that your hub motors will be the future, right? All individual four hub motors will be the future.
Yeah,
then you have very algorithm can take care of the variations in speeds when you are turning.
I'm not sure about it.
But how does I think I'm presuming still that all the inefficiencies of mechanical systems are still carried forward in electrical, except that you replace IC engine with a motor.
Mm-hmm.
I think so. Am I right or not?
Yeah. See, main thing is that the engine part, which has
that you replace with a motor, electric motor, and supply the batteries. But the rest of the steering systems, how did you change it in an electric vehicle? The current models of electric vehicles.
That is not changing. Only the
So
main
that's
thing,
what, that means you're
power
carrying
chain.
forward all the inefficiencies of the mechanical system to the electric vehicle system.
Yeah. So only thing is halving the problems what we already have. That's all.
It's
So
not happening any of the problems of the efficiency, energy conversion efficiency. In fact.
yeah.
It's just the one energy, the pollution only addressed. And that too probably miserably conceived.
But yeah, even there are arguments that it is not solving because the pollution is happening somewhere else.
Yeah. It is accumulated in the power plants.
Yeah. That's what they're saying. It is not polluting at the point of use. That's why they just want it.
So that's what this model actually, whatever is probably ideally the future car will be having hub motors, which will take care of this. The inefficiency of the mechanical systems are removed. When you have hub motors, you have 4 independent controls, right? I mean, algorithms can take over that. You can write algorithms where it can take over. So, I mean, I don't know because I read futuristic course will have hub motors. So, so they will not have the current, inefficiencies of the mechanical farm that we have today.
Ari, if I may answer that,
Lalit, go ahead.
whatever knowledge I have, the future of the electric cars is going to be to the point that you made that we are just changing the IC engine to an electric motor. That is true if you are using just one motor. And the research that is going on right now, to your point on the hub motors, that is where the electrical efficiency of this whole system lies. Just changing an IC engine to an electric motor is not going to give us any benefit. In fact, it is detrimental. It is causing more issues than solving problems. So even now, like the vehicle that we just launched from GM side, the Hummer, we have 3 motors on that. One for front wheel drive, and 2 for the rear wheels, right? So it's 3 motors, and none of them are connected to any differential. So that is the way to go. That is the only solution that currently is being shown as the efficient one.
Yeah.
You're right on point. It's not a future. It's the present right now. That's how the manufacturers are doing it.
Yeah. So the single motor is only in the entry level, the small cars, Renault or Nissan Leaf, whereas I-Pace has 2, and some of the Teslas have 2, where all-wheel drives are required. And the high-performance vehicles like maybe a Hummer and Rimac, all those people, they have independent motors for each wheels. Is that what?
Yeah, I think that's what, the independent motors controlling independent wheels are
they don't.
But then the cost goes up probably. I don't know.
Yes. That's why it's all in performance vehicles.
So energy consumption and the maintenance also, motors.
We have to.
Yeah, we have 2 questions on the chat. One is Jivek is asking, what do you think about Tesla Cybertruck styling and function? That's question number 1. Another question from Sibananda Sahu is, what is the future of solid-state batteries?
Solid-state battery is still under, I think, development, and it might reach common usage in the middle of a decade, it seems. And regarding the Cybertruck styling, it's still not clear why it is. And it's purely basic, making manufacturing easy with limited processes, so that a quick turnaround will be there. That's why they've used straight edges and kind of very edgy design. So other than that, I don't know. It's strange for many people whether to like it or not, but many old car guys, they don't like it.
Yeah, there is one other question. The electric is just offsetting pollution from cars to factories is the concern that we have. But then why the pursuit of EV is so aggressive among OEMs, despite the fact
so
that
I told you basically it's a government strategy. Although there's so many countries, there are only 24 countries that come together to push or phase out the fossil fuel. Other countries, they principally agree, but they don't want to commit. And there are car companies, VW, Toyota, and all these people, they're reluctant to sign anything, saying that we phase out by this date, because they're saying that South America and African markets are not yet matured, and they won't be able to cope up, and we have to tap that market as well. And they don't want to go by what China is promising. They're still thinking that China's electricity is produced by coal and other things, so it's not going to help. So this kind of a clash is always there. Only certain countries which can afford, they are pushing towards this to create a low carbon economy, and maybe they'll be the market leaders in future days, so that they can govern all the other, or pull or do business with other company or countries following bigger. They say like Netherlands as a big example for going green energy and other things. But Netherlands, they could do it because it's a high taxed economy, and every house has one EV, but they also have a big SUVs, gasless, and they're also supply so much of, they have so much of fossil fuel reserves which they sell. Okay. So they're able to adopt this EV switch because they're very high economy. So I don't know, it's kind of a strategy. It's maybe a political and economical thingy than a common who's the bottom of the pyramid, users. So yeah.
Madhu, you want to ask that question?
Yes, sir. Hello.
Yeah, please.
Hi, am I audible?
Yes, please go ahead.
Yeah.
Yes. So, hi, sir. That's a very lovely presentation that you provided. So, my concern is what will happen to the Indian roadside mechanics that you find on the highways or in the streets, or like in the city and all of that.
Yeah.
The one other concern I had is the sphere is moving from mechanical to electrical sector. So mechanical, at least there is a visual diagnosis which people can do, and you don't need a lot of setup infrastructure or something like that. But for electricals, you need sensors, you need monitors, and all that. So how would the people who like in the Indian context deal with all of these changes? So yeah, thanks.
Yeah, the doubt is there. Even here, there is a challenge. That's what I mentioned. Why it's risky, or it's reluctant. The legacy companies are reluctant to move quickly towards EV because there are so many things tied to it, like servicing, maintenance, and all those things. Infrastructure has to change. Basically, checking or servicing electric vehicles is easier because of the simple components, and it's more digital than the mechanical ones. So there has to be a slow change or a quick change between the current mechanical system to this. There is a risk, and people are reluctant about it.
That one question
Sure,
I have, Ari.
Yeah.
What as a designer of an automobile, those who are in automobile design, is their life changed with designing for EV vehicle, or it has not?
It's life did not change, but the attitude has changed. Like now, the design trend, design language is more towards a product kind of thing. Like earlier, they used to have automotive styling, the volume and other thing. Now it's more sharp edge and kind of a more producty thingy. So that's the general trend. See, ever since this Apple design become popular, every car started having those kind of a simple, very a minimalistic approach. So that kind of change is happening. But otherwise, EV as such, it's not pushed the design boundaries, I suppose.
Mm-hmm. Because you spoke about a lot of advantages that it throws. So have designers exploited that, and in what way have they?
Yeah, see, it's still in transition phase. At least where I'm working, it's still in a transition phase. We haven't gone fully EV. Only one car was made, that's I-Pace. So still there are a lot of carryover parts and other things. So you can't see the total radical change like a concept car. But in fit and finish wise or styling wise, it's going more towards a product. Like you see more glass, you see more displays. Mm-hmm. And those kind of things. And material-wise, they've gone for vegan material, vegan leather, than the actual leather. They're going for recycled materials, using recycled carbon fiber or other materials. So that's how they're improving, but they haven't gone into very, what do you call, radical changes
Radical changes
yet.
Okay. We are almost 10:1. I mean, maybe one time for one last question. Anyone?
If I may ask a question, Hari. This is Hari from. You talk a lot about the electric vehicles, but again in the UK and also in the Europe, what we see is an alternative market on hydrogen fuel cars. Like Toyota have already introduced the Mirai in the UK as a commercial vehicle.
Yeah, hydrogen vehicle. You mean? Yeah.
Yeah, that's right.
Yeah, I've seen few vehicles, but generally it's not yet developed, or it's taken as a positive thing among the what do you call, manufacturers. We asked the same question to our design director. He says like it's not in our thing at the moment. It's going to take a long time because it's not a proven system yet, at least in UK.
Yeah, well, definitely not in the UK, but I think in Europe, both Toyota and Hyundai have invested, I think, more than 500 million.
Yeah. See, and what I understand. Yeah. What I understand is like about how the governments are pushing towards the technology. I think hydrogen technology is being pushed in the UK, but the commercialization is not yet done, I think.
Yeah.
Because the car company has to make all these things, right? They have to manufacture.
From what I gather, it's more similar to the traditional ICE rather than having to change the design drastically. And of course, in terms of pollution, if you're looking at targeting the overall climate aspects of it, then hydrogen fuel in the whole life costing and the carbon emissions, it's going to be much lower than what a traditional IC or the electric vehicles have.
Electric vehicles, yeah.
Well,
sorry, that was my only comment.
Yeah. Well, I think we have at least 3 minutes past 10, and great, Ari. I think there are more questions that would come as people absorb the content that you have just shared. And I request any of you have any questions post this session, please post it in the WhatsApp group. We'll make sure that it reaches Ari and he is able to respond to those questions. Ari, thanks a lot. Thanks a lot for this excellent presentation. I think there are many aspects that you covered. I mean, I was just recalling what all I saw. There was this history bit of it, and there is this technical bit of it, and there is this styling and aesthetics bit to it, and a lot of these environmental, ethical questions. And I think I enjoyed this as a consumer and as a designer, and also as somebody who needs to ask these questions. And I think that you left a lot of us with a lot of questions to ask, and whenever I think we see a car next time, or we get into a debate on electric vehicles, I think we'll be much different than what we were till this presentation. I mean, frankly, I certainly would look at them very differently. So it was well put together, very nicely drawn, very nicely presented. And thanks a lot. Thanks for your time. And I know you have put in a lot of efforts.
No, that's fine. I also learned a lot in this process, to reconfirm things.
So nice.
It's
so
good.
Nice.
Thanks for your initiative. You started, and hope it was
Thank
helpful.
you so much. And thanks to all the attendees of the session today. And the recording of this we will put together, make it available tomorrow. And we have sessions coming up soon. We will intimate in the subsequent days. Thanks again, and thanks, Ari, and have a great rest of the week, and see you again next week for the next session. Thank you. Good night.
Thank you. Thanks so much, everyone. So, thank you.
Thank you.
Thank you.